What is the highest decimal number that can be represented by a certain number of bits? This is in page 9, or on page 9 in our book. And what this means is, if I've got 2 binary bits, and I want to know how high can I count with 2 binary bits, I could use a function on my calculator. The key is going to look like this. On my calculator, which is a TI-36X, the key is a y raised to the x exponent. With 2 binary bits, I would key in my calculator 2, then I would press the y to the x key, then I would press equals. I would key in 2, y to the x key, then in this next position you would key in however many bits we have. In this case we have 2 bits, 2 bits, then we'd press equals. This is basically saying 2 raised to the second power, which would be 4. Now the question I'm asking is, what is the highest decimal number that can be represented by a certain number of bits? If I take 1, 1 and convert it to decimal, you know that that is actually decimal 3. However, I want to know how high can I count if we start off with 0, 1, 2, 3, I can only count to 3 with 2 binary bits. So if we go back to our equation where we get 4, we must then subtract a 1. So with 2 binary bits, that is equal to 3 if we do the conversion, but when we're counting with 2 binary bits, this right here represents 2 binary bits. And if we start off with 0, which is 1 number, 1, which is 2 numbers, 3, which is the third number, and then, 0, 1, 2, and then 3, which is the fourth number, you'll see that this is 4 individual numbers, which means I could have 4 different numbers with 2 binary bits. But because we start counting at 0, I can only count up to 3 with 2 binary bits. So using our formula 2, y to the x key, 2 meaning how many bits, equals 4, then we must subtract 1, and we'll see that our answer is 3. I'm sorry, that doesn't show up too well, does it? Is equal to 3, and then I want to highlight our answer.